guys, I'm back with my new video, that is Introduction of Trigonometry Part 2. In the first video, we have covered two concepts, and in this video, we are going to cover next two concepts. So, we are starting with third concept, that is, let's say if we have one right angled triangle ABC, which is right angled at B. As you know, some angle properties says angle A plus angle B plus angle C is equal to 180 degree. Here angle B is 90 degree, so we are going to substitute angle B as 90 degree. It will become angle A plus 90 degree plus angle C equal to 180 degree. That will become angle A plus angle C equal to 180 minus 90, that is 90 degree. So what does this say? This says that angle A and angle C are complementary angles. Because that's a definition of complementary angles, which is sum of two angles is equal to 90 degree. But what is the relevance of this complementary angles in this concept 3? So let's take angle A. So angle C will be 90 minus angle A. Right? Sine A, as you know, is perpendicular upon hypotenuse. According to this triangle, if we are taking A as our theta, so perpendicular is BC and hypotenuse is obviously AC, which is the longest side. Similarly, cos A is equal to base upon hypotenuse. These ratios are already being done in our first video. If you don't know how to find these, please check my first video. Here we are using this cos A equal to B by H. Again, according to this A, if this is a perpendicular, then the remaining side is base, which is AB. And hypotenuse is again AC. Right? But if I have to find according to this angle C, so sine C, again, sine is perpendicular upon hypotenuse. That remains same. According to C, perpendicular is AB and hypotenuse remains same, that is AC. We can substitute C as 90 minus A because we have already found its value. Angle C is 90 minus angle A, and sine 90 minus A came out AB upon AC. But we have seen this ratio somewhere here, and this is ratio of cos A. So sine 90 minus A equal to cos A. So now we are finding for cos. Cos A is AB upon AC, as we have already seen. Cos C, according to C, this will be the base BC and hypotenuse remains the same, that is AC. Now if I substitute C as 90 minus A, as we have done in the first case, so this will remain same because C is equal to 90 minus A only. Now cos 90 minus A equal to BC upon AC. And what is this BC upon AC? As we have done it before, equal to sine A. So here we have found two results, that is cos 90 minus A is sine A and sine 90 minus A is cos A. Right? Similarly, we can find the other ratios also, that is tan 90 minus A is equal to cot A and vice versa as well, because if you put cot 90 minus A, that will come out to be tan A. Then cosec 90 minus A equal to sec A and so on. Hence, this is our concept 3, which tells if we find for the complementary angle, another trigonometric function will come out. Let's check out the question of this concept from our exercise 8.3. We are taking one question from exercise 8.3 and question number is 6, which says if ABC are interior angles of triangle ABC, then show sine of B plus C by 2 is equal to cos A by 2. That means we need a triangle ABC. Okay, so we have triangle ABC. So ABC are interior angles. That means sum of these three angles is equal to 180 degree. And we can also say this because on left hand side it is just B plus C. So we can find the value of B plus C as 180 minus A. Right? So this is to prove question, to show question. That means LHS, we have to show LHS equal to RHS. So by taking LHS firstly, this is our LHS part. So we have the value of B plus C from this 1. Let's substitute this 1 here. This will become sine 180 minus A by 2. Correct? And if I divide this 2 with every number individually, 180 by 2 and A by 2. This will become sine 90 minus A by 2. And this we have already done in this concept. Is sine 90 minus theta is equal to cos theta. And that is RHS. Hence proved. So we are simply applying this concept to get to our result. This is going to be our last topic, that is concept 4. Which says, if you know Pythagoras theorem, then this concept is very, very easy for you to remember, to find it in the exam, which says, as you know, if this is a right angle triangle ABC, and here AC is hypotenuse, AB is perpendicular, as B is 90 degree and BC is base. So according to Pythagoras theorem, AB square plus BC square is equal to AC square. Here, let's calculate the first thing to do this concept 4. Let's divide everything by right hand side. Right hand side is AC square. Divide everything by AC square. So RHS is very easy to find, that is 1, because both the values are same. But what are these AB and AC, AB upon AC and BC upon AC? Let's just find it out. If I take sine C, according to sine C, perpendicular is AB and hypotenuse is obviously AC. Similarly, cos C, base upon hypotenuse. Base is BC and hypotenuse is again AC. If I just simply substitute AB by AC is equal to sine C, this will become sine square C because it is being squared. Similarly, this will become cos square C. And this is our first identity, which is square of sine C plus square of cos C will always gives us 1. So this is the first identity that we have concluded from Pythagoras theorem. Similarly, if I divide everything by AB square, this is same, it will become 1 BC upon AB. So according to C, BC is base and AB is perpendicular. And you know base upon perpendicular is cot square C because we are taking C as our theta. AC is hypotenuse and AB is this perpendicular. So H upon P, that means reciprocal of sine, which is cosec square C. So this is our second identity, which is 1 plus cot square C equal to cosec square C. Now, third one. Again, using the Pythagoras theorem. So out of these three, we have already divided this equation with AC square, AB square. We are only left with BC square. Let's divide everything by BC square. So this is obviously 1, and let's check AB and BC. AB is perpendicular, BC is base according to C, and perpendicular upon base is tan square C. Plus 1 equal to. Let's check out this one. AC is hypotenuse, BC is base, and this is reciprocal of cos h by b, right, which is sec square C. This is our third identity, tan square C plus 1 equal to sec square C. So concept 4 gives us 3 identities. One is already here. Other two are cot square C plus 1 equal to cosec square C, and the last one and most important, that is sin square C plus cos square C equal to 1. And these angles which I have taken C here, it can be changed according to the question given. I have assumed theta as C here. It can be A, it can be anything as given in the question. So let's check out one question of this concept 4. Here we are taking question number 5, fifth part of exercise 8.4 of NCERT book, which says prove cos A minus sin A plus 1 upon cos A plus sin A minus 1 equal to this, and that is cosec A plus cot A. And it's already mentioned in the question that you have to use this identity, 1 plus cot square A equal to cosec square A. So right hand side is already giving us cosec and cot. Let's convert everything in cosec and cot term on LHS. Let's take LHS and RHS here. RHS is cosec A, which can be written as 1 by sin A, and cot A is cos A upon sin A. As you can observe, everything on RHS in denominator has sin A, correct? So let's divide numerator as well as denominator of LHS by sin A. This will give us cos A by sin A minus sin A upon sin A plus 1 upon sin A. Here I am dividing each term individually with sin A, because then only I will get cosec as well as cot A upon cos A plus sin A plus sin A upon sin A again minus 1 upon sin A. This will give us cos upon sin is cot A minus sin and sin will be cancelled out, it will become 1, and 1 upon sin is cosec A. In denominator, it will be cos by sin is again cot A, sin and sin will be cancelled out, and minus 1 upon sin A is minus cosec A. All the terms in numerator and denominator is same, but the only difference is of signs. In front of cot, both are plus, but with 1 they have different signs, similarly for cosec. Let's move to the next step. Here, cot A, if I take minus common from second and third term in the numerator, it will become 1 minus cosec A, which is same as it is in the denominator. That will be cot A plus 1 minus cosec A. Here we can see, to use this identity we should have square, but here we do not have any square, it's just simple cot and cosec. So let's rationalize these two. Now everything is in linear form. We have to convert it into square form to use that identity of cot and cosec. So let's just rationalize the part. And rationalizing says whatever is in the denominator, change the sign in between the terms. That means that plus is there, you have to use minus, and then just multiply and divide with that expression. Everything else will remain same. So here, as you can see, This is A, let's say this is B. Similarly, A and B. And we know one identity, very simple, very easy. A plus B into A minus B, which is A square minus B square. And that will become cot square A, that means square of A minus square of 1 minus cosec A whole square. In numerator, it will be, so each expression is same here as well as here. So we just square the whole term. So we get this, correct? This whole square. So now just expand the numerator. You know A minus B whole square? Obviously that was in 9th class. A minus B whole square is A square, which is cot square A, plus B square, which is 1 minus cosec A whole square, minus 2 into A into B. Here our A is cot and B is 1 minus cosec A. In denominator, it will be cot square A, and if we'll expand this again, A minus B whole square, it will be 1 plus cosec square A minus 2 into A is 1 here. So we can just write it 2 into cosec A. Right? Let's just open this bracket above in numerator as well as in denominator. Expand this expression. In numerator, cot square A will remain as it is. This 1 minus cosec A square whole square will become 1 plus cosec square A minus 2 cosec A. And this is minus 2 cot A, if we multiply this with the bracket, plus 2 cot A cosec A. Upon, just expand the bracket and change the signs. Cot square A is minus, so we are removing the bracket, signs will be changed. So after expanding everything, we are getting this. So now you must remember the identity. 1 plus cot square A equal to cosec square A. Let's just see and check where we can apply this identity. So 1 minus cot square A, here we can use, it can become cosec square A plus cosec square A minus 2 cosec A minus 2 cot A, and everything else will remain same. Upon cot square A minus 1 minus cos square A. What does that mean? If I take first and the third term, that means if I just modify this identity a little bit, so 1 is equal to cos square A minus cot square A. If I take cot square A that side, but here cot square A is in front of cosec square. That means we have to change the signs, and if you change the signs on LHS, RHS will also change. So 1 will become minus 1, and 1 minus 1 was already there, plus 2 cosec A. Correct? So now we have applied the identity in numerator as well as denominator. Let's check the next step now. Added minus 1 and minus 1 in the denominator, it will become minus 2. So moving to next step, let's take 2 cosec A common from first and second term, it will become cosec A minus 1. Similarly, from third and fourth term, let's take common plus 2 cot A. Then we'll be left with cosec A minus 1. Same. Now, let's take 2 common, and keeping plus 2 common, it will give us cosec A minus 1. Now from numerator, cosec A minus 1 is here, cosec A minus 1 is here, we can take common from this whole expression, then we'll be, and 2 also, we can take 2 common, then we'll be left with, from this expression, this is being taken common, this is being taken common, only cosec A is left. In this case, it will be only cot A upon 2 cosec A minus 1. So this whole expression will be cancelled out and we are left with that part which is on right hand side, that is cosec A plus cot A. So using that identity of 1 plus cot square A equal to cosec square A, we have solved this equation. We have covered all the 4 concepts of trigonometry, from identities to ratios to function. So my job is over. Now it's your turn. Just practice at home and do comment in the comment box wherever you face a doubt while doing the practice. And we are definitely going to discuss that in my next video, in which I'll be covering all the important questions along with your doubts. See you guys later in my next video. Goodbye. Take care. Thank you.